All puzzles result in the output of a condition that tells the blockchain what to do with the coin that it's wrapped in. An inner puzzle can be thought of as a coin within a coin, where the result is a condition that is passed to the outer puzzle, which executes it. One specific use for this functionality is if you wanted to use a generic inner puzzle and wrap it in an outer puzzle that verifies a signature. The outer puzzle can be a sort of template that you can pass in any generic inner puzzle, and it will be signature protected by the outer puzzle. Let's create this exact outer puzzle template. We're going to define a module, and for our parameters, we'll have a public key that will curry in later, an inner puzzle that will also curry in, and then the inner solution. We'll include the condition codes library file and the SHA-256 tree library file as well. And then we're going to define a new function. We'll call this calculate output. And in the parameters, we'll have our public key, the inner solution, and the conditions that we'll execute. And in a combined statement, we'll have the standard signature verification that we used in the previous video. For the message that we're verifying, we'll be verifying the inner solution, and then we'll return the conditions. Now that we've defined our new function, we'll call it with calculate output, provide the public key and the inner solution, and then we'll use the apply operator, or A, on our inner puzzle, providing the inner solution. The apply operator is how you execute some code. So the inner puzzle will be executed with the inner solution. So this puzzle will first evaluate the inner puzzle with the apply inner puzzle inner solution method, and use the result as the condition for our calculate output function. This function requires a signature of the inner solution to pass. Now let's write the inner puzzle. And for this puzzle, we're going to use a condition called assert height relative, which specifies when a coin can be spent based on the number of blocks passed since coin creation. So we'll define a module, and in our parameters, we'll curry in the required blocks. This will be a number of blocks that have to pass before the coin can be spent. And then we'll have our conditions. We'll include the condition codes library again, and then we'll define a statement that uses the assert height relative condition on the required blocks that we curry in. And then we'll return the conditions. All right, now we have both our inner puzzle and our outer puzzle. Let's curry in the needed values. First, we'll get our public key with Chia keys show, and then we'll curry the block value into the inner puzzle with cdv CLSP curry inner puzzle.clsp -a and specify the number of blocks that we want to pass. In this case, we'll use 20. We can now curry this result along with our public key into the outer puzzle with cdv CLSP curry outer puzzle.clsp -a, enter our public key, -a again, and in quotes, we'll paste the compiled inner puzzle. Now that we have our final compiled puzzle, we can go ahead and create a coin using the process that we covered in the last video. Once the coin has been created, we can create our solution for this coin. First, we get our wallet address and decode it. We'll use this in our desired solution. Again, we'll be using the create coin condition signified by the code 51. Note that I'm nesting the solution in 4 sets of parentheses. This is because the outer puzzle parameters list is passed in wrapped with parentheses, as is the inner solution. In the inner puzzle, we have another set of parentheses for the list of conditions, and each condition is also wrapped. It's important to understand the structure of the puzzle to make sure that the solution you provide is structured properly. Now we'll add the encoded solution into our spend bundle, where we already have the coin info and puzzle reveal from coin creation. Next, we'll get our signature using the method we outlined in the previous video. We'll hash our solution and concatenate it with the coin ID and Genesis challenge. Now we can sign the resulting message with Chia keys sign and copy the signature into our spend bundle, being sure to append 0x to signify that it's a value. Now run cdv rpc push transaction spend bundle.json. If the number of blocks is not yet passed, it will have a pending status. If successful, we can look up the coin record again and see that the spent block index is more than 20 blocks later than the confirmed block index. In this video, we learned how inner puzzles work and how they interact with outer puzzles. Thanks so much for watching. Catch you next time.